All right, so you've read some about water and its properties and the fact that water, because of its properties, is our universal solvent.
Right, and so we know that water can dissolve a lot of different things because it's polar. It has that partial negative charge and that partial positive charge. So it can dissolve a lot of things.
So the fact that it's a solvent means it can dissolve things. So solvent is whatever a substance is dissolving in. And that we're kind of familiar with. We've called a lot of things solvents. What you may be less familiar with is the solute. But you actually are familiar with it, you just haven't called it that. The solute is just whatever you're dissolving.
So if I'm making Kool-Aid, the solute would be the Kool-Aid, and the solvent would be the water.
Yep.
All right, sounds pretty easy. So this is the stuff we are dissolving. Okay.
Okay, so if we want to know how much stuff we can dissolve in a certain amount of solvent, we want to look at what's called a solubility curve.
Okay.
That's just a fancy name for a graph like this that has temperature on our x-axis.
Okay.
And grams of solute, the amount of stuff we can dissolve in a given amount of solvent. It's almost always 100 milliliters of water.
Okay.
So the way you make these graphs is actually really, really fussy. But you don't have to worry about it, you're just using it. So what this is telling us is if we have any point that is on our curve,
Kind of like that.
like that, that will be the maximum amount of solute we can dissolve at that temperature. It's what we call a saturated solution.
Okay, so a saturated solution is a solution that can hold, like you said, the maximum amount at that temperature.
Right. So think about when you're sweetening your tea. If you're adding sugar to your tea, can you just keep adding packets of sugar?
Eventually, you keep stirring and stirring and stirring, and it all starts to sink to the bottom. It doesn't dissolve anymore.
Right. That is a saturated solution. It's got as much dissolved in it as it can hold, and anything else just settles to the bottom. So, how do you make really, really sweet tea?
Well, I remember growing up, we'd heat it up on the stove and get it really hot. And then we'd add a whole lot of sugar. And I remember my mom saying that we had to let it cool down first before we could start drinking. And that was the perfect amount of sugar.
Right, because if you notice, our graph goes up as our temperature increases. You can dissolve more stuff for most substances at higher temperatures. If you cool it back down very carefully, you can make what's called a supersaturated solution.
Okay.
So where would points be for our supersaturated solutions?
So if I'm able to put more at that temperature, I should see something kind of like that.
Right.
So it's going to be sitting above the line.
Right. Be careful, though, because it's only supersaturated if it tells you you really dissolved that amount. If you've just added that amount, it's going to be back to your adding sugar to cold tea.
And some of it's going to dissolve, the rest of it's just going to sink to the bottom. Okay.
So what do you think is going to happen if we add solute to a point where we're somewhere below the graph?
So kind of like that?
Right.
Well, I guess that would mean if you put it in there and it's all dissolved and nothing's on the bottom, theoretically, you can add more solute. I can put more tea or sugar in the tea.
Right. That's what's called an unsaturated solution. We haven't yet hit the maximum amount we can add.
All right.
All right, so let's look at how we read a real one of these. So you've got these questions and this graph in your packet. So let's look at these. So this first question is a pretty easy question to answer. We want to answer which salt is least soluble in water at 20 degrees Celsius. Remember, all of these are in water. So we're going to look at all our curves.
All right. And it's at 20 degrees Celsius, so I presume we're going to be looking
at 20.
At 20, so we're going to be looking at this line right there.
And so if we're looking for least soluble, do you want a curve that's high on the graph or low on the graph?
I'm going to go ahead and guess that we want it low on the graph. So I want the lowest point.
You don't want very much to dissolve. So what line is lowest at 20 degrees Celsius?
When I take a look, I've got that line, and that lines up to KClO3.
Right. Just be careful to follow your lines over and get your salts.
So the salt least soluble in water at 20 degrees is KClO3.
Mm-hmm.
Okay. Let's see. Keep on going. How many grams of potassium chloride? So that's that guy right there can be dissolved in 200 grams of water at 80 degrees Celsius.
All right. So we want to start with finding our temperature.
All right.
So let's look at our temperature.
Okay, so the temperature is 80 degrees.
All right, and now we find where KCl intersects.
Which is... Let me make that a little bit better. All right, right there.
All right, so how many grams of KCl does it say we can dissolve at 80 degrees Celsius?
Well, if I follow this line across, I can do 50.
All right, but that's in 100 grams of water because that's what our graph says.
And I've got 200 grams, so I can double that number.
Right, so you take the 50 the graph says and you double it, and we get 100 grams of KCl.
Oh, okay. Oh, and so number 3 is kind of similar. I'm looking for potassium nitrate, which is...
It's got to have an N in it. Okay, NO3.
There we go. Oh, man. All right. I'm looking for 40 degrees, so right there. And where potassium nitrate and 40 degrees intersect is right there.
Okay.
So if I bring that across, that kind of looks like, I don't know, like 62?
Yeah.
Something like that.
All right, so
Can
that's...
be dissolved in 300 grams. So I want to take 162 times 3.
No, it's 62 times 3.
62. Okay, 62 times 3. I was thinking of it, 186. All right, so I can dissolve 186 grams in 300 grams of water at 400.
So be careful because your graph is pretty much always going to be in either 100 grams of water or 100 milliliters of water. So if you want some multiple of that, then you're going to want to go back and multiply. So that's what we've done.
All right. Okay. Let's get this stuff out of the way then. All right, which salt shows the least change in solubility from 0 to 100? So I'm going to look at the line that it's going to stay the flattest.
Right, and what do we call how flat or steep a line is in math?
Ooh, that's geometry. Slope.
Slope. So we're looking for the line with the least slope or the least change.
All right, so it's okay. It can't be the potassium nitrate that we just looked at because that thing's nuts. I've got some shallow ones, and I'm thinking this one.
Yep. So our sodium chloride has the least change because it's the flattest line.
Okay, very good.
See, none of these questions are very hard. They're all skills we've learned about graph reading in middle or elementary school at some point. Just be careful with what you're looking at.
All right, at 30 degrees Celsius. So there's our temperature, 30 degrees Celsius.
Okay.
90 grams of sodium nitrate, which is that one, is dissolved in 100 grams of water. Is this solution saturated, unsaturated, or supersaturated? So I'm going to go ahead and go out on a limb. I'm going to want to find 90 grams of solute, and I'm going to find where that line and 30 degrees Celsius intersect, which is right there.
All right, so what we've got to look at is that above our sodium nitrate line, is that below our sodium nitrate line, or is that on our sodium nitrate line?
It's a little bit below the sodium nitrate line.
So anytime we're below the line,
that
could we dissolve more?
Yes.
We could dissolve more, so that is
means
an
it's unsaturated
solution.
All right.
There we go.
All right, this is pretty easy.
Yeah, so why don't you try these next ones on your own for a second, and then come back in a minute and see how you did. Alright, so hopefully you tried these on your own. This next one gets a teeny bit more complicated, but not that much. So question 6 is saying we've got a saturated solution of potassium chlorate formed from 100 grams of water. If the saturated solution is cooled from 80 degrees Celsius to 50 degrees Celsius, how many grams of precipitate are formed? So we talked about precipitates way back when we were doing chemical and physical changes.
Right.
So what was a precipitate?
A precipitate is a solid product or a solid substance that comes out of solution, so kind of like it settles out.
Right, so this is like we were talking about if you have tea and you just keep adding packets of sugar, that sugar that falls down to the bottom of the glass is your precipitate.
Okay, so we're trying to figure out how much of that we are making when we cool down the potassium chlorate.
Right, so let's go back and look at our graph.
All right.
So we want to start at the 80 degrees Celsius that it talks about.
Okay, so here's 80 degrees Celsius.
And so we want to figure out where we are for our potassium chlorate at 80 degrees Celsius. So let's look at our graph.
So potassium chlorate for 80 degrees Celsius is about there-ish.
So it's right about 40 grams.
Okay.
And so now we're going to cool down
to 50.
To 50.
So the second one is 50.
Mm-hmm.
And it crosses the line about there, which means it goes down to 20.
So we could dissolve 40 grams at 80 degrees Celsius. We're cooling down our solution. At 50 degrees, we can only dissolve 20 grams. So what happens to that other 20 grams?
That's the stuff that forms the precipitate.
That's going to be our precipitate.
So we should get
40 minus 20, which is
20 grams of precipitate.
All right.
All right.
So these next couple are actually a whole lot easier. Let's go back to our graph. We want to know what compound shows a decrease in solubility over the course of our graph.
So the temperature's going up, but we're actually looking for something where the solubility is going down. So the line should be sloping downwards in the opposite direction.
Right.
Okay.
And so most things get more soluble. There's a couple of exceptions.
Okay, so I can see that that one goes down.
Right, so our cerium sulfate, but there's one other one.
And that one goes down.
So both of those compounds show a decrease in solubility. And something you probably want to note about NH3, the reason NH3 goes down is because ammonia
is a gas.
So it's like carbon dioxide in your soda. When's your soda more likely to fizz up all over you?
When it's hot.
Yes, so a hot soda is more likely to fizz over because gases are less soluble.
And so that's why you want to keep it in the refrigerator after you've opened it.
Right.
To keep the gas in there.
All right.
Rock on. Okay. So which we wanted?
So just write down the two that we did.
Right,
so it was NH3 and then that other one. But make a note that NH3 is a gas and gases are less soluble at high temperatures. All right.
Okay.
So these last three, we want which salt is most soluble at 10 degrees Celsius. We've done a least soluble. So most is going to be where on our graph?
Most is going to be at the top. So
all right, so we're looking at 10 degrees Celsius.
10 degrees Celsius is right there.
So we got to go all the way up.
All the way up to the top. Dun, 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 dun. Right there. So the most soluble at 10 degrees Celsius is Ki, the potassium iodide.
Yep.
All right.
And then least soluble, we already looked at one like that, but this one's at 50.
Okay, so then we need to look at 50. We want the lowest one, which is
our Ce2SO43, which, by the way, is cerium sulfate.
All right, so it was... let's see, the lowest one was...
Did we actually hit record again?
Yeah, it's running.
Okay.
Okay, so the lowest one was the
Ce2SO4
3.
All right, and then we want least soluble at 90,
so which
is going to be the same again.
The same one. So, ditto.
All right. So if you're still having issues with this, ask us questions. Otherwise, go on and work on your independent practice.
Bye.